Good day, guys. We're talking about integration, but the part of integration we're talking about mainly is this idiot sub. Actually, I can't call it idiot though. This Euler sub, but it deals with integration, and Euler sub are like three categories, but I'll only explain the first category. And mainly it talks about just integrating a particular function, which is in terms of rational of x, and also giving you a particular value of x and also a quadratic function of ax squared plus bx plus c. Let me just put it that way. And we know our dx. So therefore, the r being a rational function, Euler's, don't let me say Euler, don't let me say Euler's. Euler was able to bring a good logic, which is most people call it the T-sum, but they were not able to categorize it categorically. So whenever you are solving integration, it feels so hard to know when to use them. So that is why I'm trying to explain some things under it. And let's talk about the Euler's first sub. The Euler's first sub. And talking about the Euler's first sub, talking about the Euler's first sub, let's say a process where you're being given a particular integral like the x over root. Okay, let me even use this other one to still explain some things. Before we move on to let's talk about the Euler first sub using this question to explain some things. Now, mainly, I want to explain this to you guys. What we need more to differentiate some functions. So I'll use this as an example to explain the Euler's first sub in terms of integrating it. So let's say you have your roots ax squared plus bx plus c. Now, Euler first sub tells us that a process whereby a is greater than 0. This function here will be equal to a plus or negative sign of your x with a plus the variable t being added to it. And after it has been equals to this, what you just have to do is what? Evaluate and find your x. Then whenever you are being given your x, you also find your, what do they call it, your dx over the t, and we are going to go to integrate whenever we are being asked to integrate. Now when you look at this question, automatically it looks familiar. Look at this question, it looks familiar, and putting x squared plus 1 here, you can have your arc sign. Putting x squared minus 1 here, you can have your, what do they call it, your arc cos. But mainly, let's break some things down to understand better. Now from here, we square both sides, right? And we'll be given ax squared plus bx plus c equals to your, your plus or minus x root a plus t raised to power 2. Raised to power 2. And moving on to this, you can have your ax squared plus your bx plus c equals to, I actually want to just break it down so that you can understand the steppings and how I actually got my value. Plus or minus of x root a plus c. So you have your ax squared here plus bx plus our c, which will be equals to your this now times this. Plus plus gives us plus, minus minus gives us plus, so automatically this will give us a plus value. So we just have to put x root a, which is wrong. Root a times root a gives us ordinary a. Surd law, if you don't know that, go and check out surd. And that will be a x times x, your ax squared, right? Then this now, you have your plus or minus. This times this gives us xt root a. This gives us also st root a. So that will be just addition of 2st root a. That will be 2st root a plus your t squared. Are you with me? Then this cancel out this. Then moving on to this now, bx plus or minus 2xt root a can be equals to your t squared minus c. Then you know now, using change of set of formula by what? By debunking on your factorization, little bit factorization. Your x is common to both of them. You can make that to x, and you have your b plus or minus 2t your root a equals to t squared minus your c. So therefore our x will automatically be equal to t squared minus c over b plus or minus 2t root a. But here guys, we aren't done with this. We aren't done simply because there's a way we can still put this thing in order. You can put your minus outside there and you have c minus t squared. Yes, and you can put your minus outside there, you'll be having plus or minus of your 2t root a, then minus b. So minus can still cancel out minus. So automatically our x will be equals to c minus t squared over plus or minus 2t root a, then minus our b. Now guys, this x is the variable we need to solve some questions like this, And most cases, note that this c is a constant value. Now let's come back to this to explain it using this integral form. Let's say you are being given x squared plus c. This Euler sub. So we present that a is greater than 0. We know that coefficient of x squared is automatically 1. So we can easily say that from x squared plus c, it can be equals to, let's use a negative. Now either use a positive or negative sign. You see how at your junction. Are you get what I'm saying? Because most cases it might convert to an absolute value, whereby it will still change the negative value to a positive value. So therefore, let's just use the negative value. You'll be having minus of x root a, right, plus t, adding our variable there, and root a, which is 1 here, that will be automatically 1, and that will be plus t. So we square both sides, right? You have x squared plus c equals to minus x plus t, then minus x plus t. As we all know, this will be x squared plus c simply equals to x squared, right, then plus 2xt, x times t, xt, not plus, minus 2xt plus t squared. Then we all know that this will cancel out this. We are finding a way by this, it has to be in terms of this variable back. That's what I'm trying to explain here. So coming back here, you have 2xt equals to t squared minus c, and your x will be equal to t squared minus c over 2t. Now I've gotten our x value variable here. Are you get what I'm saying? And we have to just find a way by this has to be equal to this. And let me start from there. Now since it's automatically x, you know your minus now, you can have minus. Before you come to the differentiation of it, this is the x, just like you say 1 over this, then times the x. So we have to find the x over the t, but not yet time for that. Making this value, or let's just differentiate first of all. Our the x now over the t, we all know that this is u over our v, a quotient rule function. So we have v squared, and that will be you have v squared, or I say v squared, v du dx minus u the v over dx over our v squared. Are you with me? And then that will be equals to your v, which is our 2t times our du dx, which is our 2t also. This is a constant, so we'll be presenting that as a constant variable, minus our u, which is c squared minus c, then our dv dx, which will give us automatically 2, over our v squared, which is 2t raised to power 2. Are you with me? Then moving on to this now, our dx over the t would be equals to, you have 4t minus this is 2t squared minus 2c, that will be minus 2t squared then plus 2c over, you have 4t squared, right? Then moving on to this will be giving us 2t squared plus 2c over 4t squared. You know now this you can put 2 inside bracket, and all these small you can put inside bracket, then you have your 2 into bracket, t squared plus c abi over 4t squared. Let's just say you can also put 2 then 2t squared. So 2 cancel out, then our dx now would over the t will simply be equals to t squared plus c over 2t squared, right? And we cross multiply, you have the, let's say the x 2t squared is equals to the t, are you with me, t squared plus c. So you are only been given the x, so therefore our dx also is just the same thing. The t adding into the variable, you still be having the x being equals to t squared plus c over 2t squared dt, just to make it look more like a function of the x here. Are you getting what I'm saying? Then we balance this idiot, then come back to here. Now we have our root x squared plus c being equals to minus x, and our x is what? T squared. So that will be minus t squared plus c over 2t plus our t variable minus x, that's minus t squared plus c over our 2t plus t variable, and your SCM will be 2t here. You have minus t squared plus c, then this will give us 2t squared, that's plus 2t squared, and this will be equals to t squared plus c over 2t. Are you getting what I'm saying? Then now shifting all this whole value into the integral, all this whole value into the integral, you'll be having integrating 1 over, now, root s squared plus c, that's the x, would be equals to integrating 1 over root x square plus c is what? Your t square plus c over 2t times our the x, which is t square plus c over 2t squared, right? And they all will be giving us the t. Without not much time, this will give me 2t over, okay, let me just put it down back to make it easier for myself. 2t over t square plus c times t square plus c over 2t squared. We all have our dt. This cancel out this cancel out this. You'll be left with integrating dt over t. And integrating dt over t will automatically give us in of absolute value of t plus c. And what is our t? From here, this question here, we all know that our t can be equals to root x squared plus c plus our x. Changing the variable here. So therefore now, this will be equals to in of x squared. Are you with me? That's in of root x squared plus c, then plus our x variable, then plus our constant. So therefore now, if you are, like I said, if you are to shift c, so this is our answer automatically when you are dealing with this variable, which feels a little bit simple, like I said. So that will be in root x squared plus c plus x, then plus c.